So we're going to do a similar exercise to the one you have in your assignment. Now we got a room, and I'm going to write dimensions of the room. So I'm going to say we got 10 meters. I'm going to say we got 2.9 meters. And I'm going to say that we got here 6 meters. Okay, and that is the beginning of the assignment. We got a work surface here. I'm going to draw like that, and I'm going to say that work surface is 0.9 meters high. Okay, and I want in this work surface, let's say 300 lux. And that is the beginning of the exercise. Let's look at two other sources of information. I talked to you about a maintenance factor. So we have a maintenance factor of, let's say, I don't know, I'm going to put here 0.8. And I'm going to also think of a utilization factor, and that actually I'm going to call it the same number, 9.8, and that will be the utilization factor. Okay, now we have the LDL. And now what is that LDL? That is the light design in lumens. So I'm going to say here light design lumens. So these are the lumens that the light has by design. And I'm going to say we got lights in that room, and these lights are going to have 3000 lumens. Okay? That's good. Now, what we are going to do is use the formula that appears in your assignment paper. And this is N equals, because I got a ruler, I'm going to make this prettier. And we got E times A, and then you got F times UF times MF. Very good. Now, we know already the utilization factor, 0.8, and we got also the maintenance factor, 0.8, and we want to find the number of lights required. So I'm going to write here N is the required number of lights. F is going to be the average luminous flux from each lamp. So luminous flux per lamp. that is utilization factor, and that is maintenance factor. This is the required level of light. And A is the area. Very good, very good. Now, I want to use the whole area of that floor. So, because I want to be able to put tables wherever I want them, maybe against the wall in the corner, maybe in the center, and I want to have the same level of light. So, the area is equal to one side by the other side. So that's 6 times 10. Our area is 60 square meters. So that's one value that we have found already. Now, what is the required level of light? Is told, and that is 300 lux. So E, I'm going to write it here as 300 lux. Now, what is the luminous flux per lamp? We're going to say is here 3000. So F equals 3000 lumens. Another thing we are looking now is this and this. I'm going to write it because I'm making a list. I write it here. 0.8 and MF equals 0.8. Okay, let's then rewrite this formula in here with the values that we have. So the number of lights required is equal to, make it pretty again, E, which is 300 times 60, and I'm going to put equal here. I'm coming a little bit lower because I got that there. And then we said F to be 3000, and we got times 0.8 times 0.8. Now, is this difficult? Yes, very difficult. I'm not going to use formula, I'm going to do one by one. So 300 times 60, that's going to be what? I don't need a calculator for that. And that is our first value. Now, 3000 times 0.8 times 0.8, I'm going to use the calculator and I'm going to write here 3000 times 0.8, and that's equal to, and that is times 0.8, and that's equal to, and I got this number. Now, I am going to divide. Oh, sorry. And I got this figure. 9.4. Now, we got a situation here. I'm going to explain why. Well, this is a decimal number, so we can have 9.4 lights. If we have this room, and I'm going to draw it, this room, and in scale, because that's what you need to do really in your exercise, sort of. So I'm going to make 10 meters so 10 centimeters, and 6. So this is our room. Okay. Now, what we need to do is to arrange these lights. And let's say this needs to be done. I explain this later on, but basically you're going to have like there's 9 lights. You're going to have 9 lights in your ceiling distributed there, but the answer is 9.4. Now, either you ignore this 0.4 and neglect it, saying that in reality you're going to have sufficient light in the room, or you're going to have to increase it. Now, in order to have a nice distribution of lights, maybe you want to go to 12, because in this case you will have 4, 4, and 4. 3 times 4, I write it here, is 12. Now, maybe, in all honesty, maybe we need to lower the lights a little bit, maybe with cables, and just put 9. In fact, in this exercise we did not have so much the height taken into account, as we already have been given all the rest of the information. In practical terms, if you ask me, I put 9 lights in the ceiling. Ignore this fraction, this decimals there, and maybe you want to hang them a little bit lower, maybe, and that will give you sufficient light. Now, you need to make this drawing as well, because it's part 2 of your assignment question, and I already done a little bit of question 3 in this instance, because I was talking about whether the design is acceptable and justify your conclusion, which is task 3. I think this is a distinction question, and I cannot give you everything. You're going to have to take it from here. This is all I'm going to say. And this is the end of this tutorial.